Okay, I guess we're all set. Ladies and gentlemen, welcome to the ESC Theater 2. My name is Arthur Friedrich. I'm an engineering manager, and I've worked in embedded systems, aircraft, military-type systems for the past 25 years, and I'm currently working on a flight recording system. And my presentation here is sort of the observations I've made over the past 25 years. And basically, it's the role of deliberate practice and how to achieve expert performance. As an engineering manager, one of the things I've noticed is that the capabilities of people are uneven at best. You know, some are really good, a lot of people are medium, and some are really bad. So how does this happen? Why does this happen? What can we as managers do about it? So if you'll just bear with me, we'll get started. Okay, this is the basic outline of the presentation, the need for expert knowledge, what is an expert. I go into the Dreyfus Model, which is rather important to understand the various levels of expertise, and then we'll get into actually how to achieve expertise with the concept of deliberate practice. Lastly, I'll go into the importance of attitude. Okay. So the main idea that I'd like to get across to everybody here is that every single one of us is capable of expert performance. We're not born with it. The muses don't breathe life into us. It takes hard work and it takes dedication. And what I'd like to relate to you in this presentation is how to actually go about it. So this fellow, his name is Walter von der Vogelweide. He's a 12th century German poet. And you guys may be wondering, what on earth does medieval poetry have to do with software development? Well, just bear with me for a second and you'll see the relevance. This was your 12th century rock star. When he sang and he recited his poetry, the ladies of the court swooned. And while his poems were stylized and he had a method, or dare I say process, the works, his writings were works of genius nevertheless. So when he died, his followers thought, well, yes, we have process, we too can produce great works of genius. Of course, it didn't work out that way. And if anybody wants to know the effect of that, come talk to me after. It's a bit rude. Anyway, 800 years later, Capers-Jones rediscovers a medieval truth. And that's basically what it says is that you need to have the capability to do the job and not just process alone. So if we look at, like this paper was published last year, and you can see it's the number of software failures is really quite high. 1/3 of programs are canceled outright. I mean, how many millions of dollars are lost? 1/3 deliver something, but it's not what the customer wants. It's often shelfware, and then most others have large cost and schedule overruns. So what's quite apparent is that project failure is independent of process. That is, i.e., process is not enough. There's something else that you need to do. So what is that? I can't name these companies, but I'll give you an example. The first company I actually worked for at one time, it no longer exists. But we had a $2 billion naval systems program. Now, what happened with this program, it was for the modernization and update of the Canadian destroyer program. And the idea was that computers would be distributed around the ship so that if the ship took a hit, the fighting could continue without the whole system dying. Well, that was all great in theory. We had all kinds of senior engineers concoct a design and network. The problem was the network was notoriously unstable. It would come up, but as soon as you tried to pass a message, the network would go down. Now, the company kept reporting progress. I mean, we were working on other software, except the key element, the network, just wasn't a living entity at the time. So the Crown, or as the Canadian government is known at the time, threatened the company and says, either you get the network up and running or we yank the contract. So, you can imagine with a several billion-dollar contract, the management started to panic. So what happened was they hired a few contractors, 3 in fact, and what's amazing about these fellows was within a week they had identified the problem, and within another week they had implemented a fix, and then the network was remarkably stable. So now let's look at Company B. This company is still around. It's quite a large organization, and they're having similar problems. They're upgrading a factory automation system, and with the aging workforce, it's quite a lucrative business, and yet they failed 3 times, and they resurrected it 3 times. The money was just too lucrative to walk away from, so they were willing to eat the cost and hopefully try and resurrect the project. Except for the 4th time, they got wise and they hired some expert contractors who knew what they were doing. So when it comes down to it, it doesn't matter what the organizational structure is, what processes you have. If you don't have the technical capability to pull it off, you're going to flop. Okay? So when these 3 guys came in to rescue the first company, I talked to them, and I asked, I was wondering, all of us, about 100 of us, we could not figure out why the network was unstable. So I asked, what skills did these guys have? What did they know that the rest of us didn't? And how did they get those skills? Well, it turns out one was an engineer, one was a comp sci grad, and one didn't have a degree at all. And yet they had something that the rest of us did not. So the question that we have to ask ourselves is, can the average programmer acquire that level of expertise that these 3 guys had? And of course, I believe it to be true. So when we look at the average developer, and it isn't just the average developer. This is across the professional spectrum. What we find is that people will reach a plateau, and they're stuck at a level that is at, how I say, less than what they're capable of. And for some reason, any progress beyond that level is impossible or rather difficult. Give them something hard, they flounder. But what's even worse is that your performance can deteriorate over time. And when I read Anderson's article about medical doctors that go into a decline the longer they're out of medical school, I knew it also applied to software engineers. So when we look at what is an expert developer, I mean, it's quite obvious they do better work than the average. Their work is of higher quality. But the absolutely key element here is that they can solve extraordinarily difficult problems. So, I mean, if the expert contractor doesn't perform, his children don't eat. It's that simple. Well, maybe not. I mean, there's other ways, but... Oops, sorry. Okay. Okay, this is a chart that I got from Watts Humphrey, and this is from a group of 810 supposedly experienced software engineers, all relatively equal. And what you can see here is that there's a 5-to-1 difference in the rate of errors which they're injecting into their code. From the 4th quartile, which is the worst, to the first, which is the best. Now the question is, how do we get our staff, our people, to sort of shift to the 1st quartile? It's not an easy problem to solve, and but you can do it, and it will take work. If we compare experts with experienced non-experts, we start to see a pattern. If you look at the side where I outline experts, you can see that they enjoy solving problems, and they will deliberately seek out difficult problems for the sole purpose of learning more, and their entire career results in an increasing progression of capability. The experienced non-expert, on the other hand, they love routine, they carry out routine, and they may be very, very good at it. And this is not to say that the non-expert doesn't solve problems. They do, but it's for problems of a routine nature which they don't have to extend themselves. So if experts are so good, why don't we just get more of them? Well, the problem is there are just not enough there are not enough experts around. They're thin on the ground. So there are a number of solutions. If you look for item 1, whole libraries have been written and about how to hire, how to attract, how to get the very best people. The problem is, though, is because they're so rare, the really good ones will apply for maybe 4 jobs in their lifetime. And if you're a company that's starting out, or even if you're a big company, these are rather thin odds. The second approach, which a lot of companies do, they hire the expert contractors. But the problem with that is that at the end of the contract, they walk out the door and into the offices of your competitor. And what's worse is they take all that knowledge with them. So the only real choice that we have is to nurture our own expertise. But be warned, this is not for anybody who expects instant gratification. It's a long-term effort, and it takes time. So before we get into how to acquire expertise, I'm going to go through the Dreyfus Model. This model was developed by Hewitt and Stuart Dreyfus. One is a mathematician, the other is a philosopher. And what they tried to do during the early days of the artificial intelligence movement was they tried to understand how people learned. And with that study, they came up with these 5 levels, going from novice right up to expert. So let's look at the first one, the novice. This is your guy. He's right out of school, no experience. You're not hiring this guy for performance. You're hiring him for potential. Basically, what these guys are good for is you give them a set of simple instructions, go do it, and they'll go off. They cannot tell what's important and what's not important. Now, the second level is the advanced beginner. 1 to 2 years of experience. Performance starts to get reasonably good, and he starts to appreciate the context in which those rules apply. However, he still treats those rules or guidelines equally and still cannot tell what is important. Okay, level 3 is the competent. Now, this guy or lady, 2 to 3 years of experience, and performance can be really quite good, and it can be good enough for promotion. So at this level, he or she starts to look at plans and goals, plans establish perspective, and they start looking at problems as a whole. Now, there's one thing you have to remember about the competent performer. He's level 3. He's still rules-based and he's still routine-based, and he may be very, very good at it. But one of the key elements here is that at this level, his performance or his or her performance becomes automatic, and what this signifies is that the cognitive load is lessened. A person can do something relatively easily without thinking hard about it. Now, what this means is that educational opportunities for this person are squandered because he could be doing more, he could be contemplating how to improve things. But what usually happens is that this results in the plateau effect. Likewise, just because you can do routine tasks very easily, you are not an expert at this level. So the 4th level is the proficient performer. This is the first place where true intuition comes in. If you've ever watched people of this type, when they solve a problem, they have no methodology, they have no set of rules, they know what the problem is, and it's almost magical to behold. However, the proficient still has to apply rules in order to solve that problem. Likewise, when considering how to solve the problem, fewer options are considered. Okay, this is the pinnacle of the Dreyfus ladder, and this person has an enormous grasp of theory, and it's backed up by vast experience. Now, here is where intuition is used in its entirety. These guys, they will zero in on a problem without considering any irrelevant alternatives. Likewise, they use their intuition to solve problems. And what it appears is, if you watch these guys either in problem detection or resolution, there's no method, there's no rules which you can follow that by which you can surmise how they solve that problem. So let's talk about intuition for a second. This is not your Aunt Edna's intuition where she says your girlfriend is, whatever. This is the ability to solve very difficult problems without a seeming methodology or a set of rules. And in fact, it's impossible to formulate a set of rules that will duplicate expert performance. Now, the only drawback with the use of intuition is that it can be unreliable in new situations, and so it's always wise to verify. Now, when we look at the population distribution, you can see that it's skewed. If you remember your statistics class, what happens when there's a skewed distribution? That means that there's some outside force or effect that's keeping it from being a normal distribution, and we'll get into that later. If you'll notice the expert, that's typically 1 to 5% of the population. Those are very thin odds. So, likewise, guess where most managers come from? Which group? So when we look at why the population is skewed, some of the reasons that have been expounded on. One is people get comfortable. They get good at their jobs, and there's no incentive, there's no desire to improve beyond that. Likewise, for the last item, Andy Hunt said that for those experts who do climb the Dreyfus ladder, they end up getting fired because they know more than their managers. But that's another story. Okay, let's get into how to become an expert. What are the steps? We know what experts can do. We know what experienced non-experts do. So how do we climb the Dreyfus ladder to true expertise? And we use a concept called deliberate practice. Okay. The reference at the bottom, the whole idea of deliberate practice comes from Anders Ericsson in his landmark paper in 1993 on the role of deliberate practice and expert performance. Dr. Ericsson, I believe he's still at the University of Florida. But the main idea behind deliberate practice is that you stretch yourself, you get out of your comfort zone, and you try things that are hard and not the stuff that's easy. The problem is there isn't a single commercial organization that knows how to push its people to this level. And in fact, the only two organizations that I know of are the U.S. Marines and the Canadian Army. But you wouldn't want your manager to be a DI, yelling you code, code, code. So from a software perspective, we have to learn how to achieve expertise on our own. Okay, there are 5 themes in how to apply deliberate practice to your daily, to your job, your hobbies, your life. A lot of these items can be combined, but I'll explain them singly for understandability. So let's look at the first one, setting goals. So what do we want to accomplish with our job? What do we want to accomplish in life? You may want to be a Linux kernel geek or whatever. But one thing, you have to be aware of your own ignorance, and you have to be dissatisfied with your performance. If you are satisfied, you will never get to this point. There's no sense in setting a goal if you're happy with the way you are. And likewise, a key element is to take responsibility for your own improvement. Now, just a warning though, a vow to improve yourself is not enough. You have to have a concrete plan of action. Now, one of the best ways that I know of is to use the SMART technique. That stands for specific, measurable, achievable, realistic, time-bound. There's more than enough of this technique on the web, so I won't go into it further. But just be aware that top performers set goals and mediocre performers do not. And setting a goal is very important. It's absolutely critical for if you want to reach a high level of performance. Okay, the second element sounds fairly straightforward. Acquire knowledge, but I'd like to point out the power of self-study. One of the things that that really surprised me when I was reading Steve McConnell's Code Complete, I came across a passage where he said that most software developers read less than one book a year. I mean, come on, guys, this is functional illiteracy almost, you know. And he goes on to say to state that if you read just one programming book every 2 months, you will vault ahead of your peers. Likewise, reading is not enough by itself. You have to test yourself if you want to retain what you've learned. You've all seen, there are many speakers at this conference that talk about the value of code inspections. They're absolutely marvelous for finding defects, but they have a second and more profound purpose, and that is to teach, specifically to teach other engineers who are not working on your code, have them inspect, have them look at theirs, understand what's going on. This way, if somebody falls sick or ill, you can take over with no difficulties. And likewise, looking for errors in someone else's code is a great way to hone your own abilities. In my teams, we have a motto: everybody inspects, everything is inspected. The attitude that we have is that, you know, especially if the senior managers say, well, we haven't got time to inspect, and I tell them, would you rather be 2 weeks late or 6 months late? You know, take your choice. So inspection is a marvelous way of doing it. So, and then when it comes to your job, don't just do it. Don't just write code. Think of how you can do it better. Think of how think of applying new techniques or new tools. And if you do take the time to think hard, you'll gain a deeper insight into the code, and you'll be aware of new learning opportunities as they appear. Of course, there's a standard here, taking courses. You can go to conferences. This is the ESC is a marvelous place to come to. Likewise, if you can't go to conferences, there's all kinds of journals, journals to read, whether it's online or in print. Now, a lot of companies have code repositories, and what I would suggest is have a look at some of the code that somebody else has written. Go through it, try to understand it, look at their comments. And above all, ask questions. Don't be shy. So, applying what you learn. Reading is fine, but you have to practice what you learn. If you have an opportunity to do it on the job, great. If not, pick a home project. I think this one's kind of cute here. One of the things that I've noticed and the experts that I've talked to, every single one of them has done a home project, whether it's wiring up their house for heat or having a remote car starter or whatever. at the Boston conference, some fellow said, just put diamonds on this little box, give it to your wife, and find out where she's spending your money. But so there's all kinds of things you can do. A very good way of not only sharing your knowledge, but also learning and gaining benefit from that knowledge is to mentor and to teach master classes. Now, one of the things about mentoring is that the mentor actually benefits more from the interaction than the person who's being mentored. And that's typically, I know it can be a pain in the neck at times when the junior comes up to you and asks, how do you do this, how do you do that? And I was actually glad that that person did, because I had to think, because I had forgotten how to do it. So mentoring, not only do you help the other person learn, it also keeps your own skills alive. So it's very, very important. And likewise, mentors and teachers see things that the average student does not. So it's very, very valuable, especially amongst the team. Should help, as much as possible, help each other out to learn, to understand what's going on. So mentoring, the thing about mentoring is that it's not the answer that's important. It's the journey on how you get to that answer. So it's not spoon feeding, it's not hand holding, and it's not giving the person everything that he or she asks for. You have to let them struggle, you have to let them figure it out for themselves. Now, on the other hand, don't torture the person, and if they're having a bit of trouble, give them a bit more help, but you'll find over time is that that effort to mentor will lessen somewhat, and they may even come up with a better answer than you have. I'd like to speak a bit about master classes. This is something I've used in my groups, and it was originally used in music education. This is where the aspiring diva sings in front of the master and an audience. Well, you can do the same thing with software. If one of your junior engineers has a bug that he or she can't solve, as a design or a coding issue, why not have a master class? A typical setting would be a team meeting. It's absolutely marvelous. Have that person go through it, explain, have the rest of the team listen, and you as the senior engineer guide that person through. Now, there's a very, very good reason for this. It allows you to leverage the experience of one person for the benefit of all. And in fact, one of the roads to expertise is to expose yourself to as many problems, as many difficulties, as many new ideas as you can. And the idea of the master class where someone explains a difficulty and the team listens in, the entire team benefits. So it's an absolutely marvelous way of doing it. Now, on my teams, we typically used it for bug fixing or catching problems. Now, one of the things to understand about bug fixing is that it's not a deductive or it's not an inductive process. In fact, it uses a logic technique called abduction, and abduction is sort of it's backwards from deduction, i.e., you have a series of events or facts that may or may not be connected, and then using your intuition, you surmise what the problem is. Now, where have we heard the word intuition before? So that's where expertise comes in. But by exposing your people to as many problems as you can, you're giving them the experience. Now, there's a lot of tools, a lot of techniques used to avoid problems up front, but what I'm telling you is you'd better have good debugging capability, because like it or not, there will always be a bug. Hopefully they won't be very difficult. And with current projects chewing up half their time in the debug phase, you'd better have someone that's capable at the back end to debug your problems. Okay. Again, on our teams, we had the motto, everybody is taught bug fixing. When we had a master class, everybody sits in. Okay, the fourth element of deliberate practices is feedback, and this is absolutely critical. You cannot improve if you don't know how well or how badly you're doing. And in fact, if you don't do anything else, at least get feedback on how things are going on your job. And in fact, feedback is so important that it can be considered a competitive advantage. If you're not receiving feedback for your job, seek it out, ask people how you're doing. Even if that feedback is painful, it is better than not knowing at all. One of the things about as you're developing your level of expertise, as you're progressing up the Dreyfus ladder, you'll soon outpace your mentors, you'll outpace your peers, even your boss. So how do you keep on improving when all of these other sources of feedback are no longer capable of doing the job? Well, you have to learn how to self-coach, and you have to learn how to assess your own performance honestly. So a very good way of doing that is to keep a private diary. I mean, what progress have you made? What went well? What didn't go well? How many errors have you made? And you don't have to show this to your manager. But above all, reflect on your experiences and think deeply as to how things could be improved. Now, when it comes to feedback, this is a rather startling. I was surprised when I saw this. A typical non-expert, they'll attribute failure to anything. It's a failure of process. So-and-so didn't deliver their software on time, so we couldn't do ours. Any excuse under the sun, and often it sounds like science fiction, whereas an expert developer, it doesn't matter what happened, what disaster what disaster occurred, they will always attribute some portion of the failure to themselves, and they'll think, what could they have done to improve the situation. Okay, the last element of deliberate practice is to take corrective action, and here you should take a two-pronged approach. Of course, you'll fix what didn't go well or what went wrong, but the second element is to even if things did go well, try to improve upon them, try to make them even better. So let's have a look at deliberate practice. I mean, when I said this wasn't an overnight or a 2-week thing, Dr. Erickson determined that it took roughly 10 years or 10,000 hours of effort to go from novice to the expert level. Now, that works out to roughly 4 hours a day, 5 days a week. But if you try to start off at a 4 hours a day, I mean, you'd quit within 2 weeks. So why not take part of those 4 hours as part of your job? Take the time to study a problem more thoroughly, more deeply, try and ask about it. At home, if you spend half an hour to an hour a day, that's absolutely marvelous. One of my lead engineers suddenly had twins, and the only time he could devote to study was a half hour when the kids were in the bathtub. So use what opportunities you can. So, I mean, if deliberate practice were easy, everybody would do it. It can be incredibly boring at times. I mean, your friends are at a party on Saturday night, so what do you want to do? Study a programming book or go out party? But you have to be disciplined about your own self-improvement. And the thing is, with deliberate practice, you may not notice or recognize benefits immediately, but they will accumulate and they will grow over time. And in fact, the one way to tell who is going to become an expert and who is not is by their persistence. In fact, it is the only way you can improve. So this chart here, what I want to explain here is that while it's true that it takes 10 years to go from novice to expert level, what's unrecognized by a lot of people is that you don't have to spend the 10 years if you're not going the full length. If you're like, let's say, at the advanced beginner stage and you want to surpass the general population, use deliberate practice and vault over the average. To illustrate an example, I hired a gentleman by reputation. I knew he was good, but it wasn't until after he had worked for me for a couple of months that I realized how good he was. And it wasn't the fact that he was, again, born with it. I had a middleware problem that I needed solved, so I hired this contractor. And he said, "Yes, sir, I can do it. Give me some time." Well, over a period of 3 months, he started learning the system, and he became so good that he surpassed the team lead. So when the contract was over, I asked him, "How did he do that? What did you do?" Now, I'll have to admit this is an extreme case, but what he did was he would take the manuals home with him, he would take the documentation home, he would study them until midnight. Now, you obviously need an understanding wife if you want to get away with that sort of thing. But being a contractor, he also took, I think, 1 or 2 months off cruising in the South Seas. So I think his wife put up with it for that reason. So let's talk about the plateau effect. And this is one that affects, I think, a lot of people. As we're progressing in our careers, naturally we get reasonably good at what we do, our confidence grows. Unfortunately, our capability doesn't follow suit. So when you think of it, why is that? It's not that people are bad or they're incompetent. They're actually very good. And here's the rub. After a few years, if you become satisfied with your performance, any further improvement becomes impossible, either very difficult or hard. Remember, one of the precepts was you have to be dissatisfied. The moment you become satisfied with the way you do, the door to any greatness you might have achieved is slammed shut, and it's often slammed shut for the rest of your career. So you also have to realize that as you improve, you may have to improve, or you may have to change the way you study in order to improve further. Now, to illustrate, I'd like to use an example by Stuart Dreyfus at a university chess club. Now, this chess club, he divided up into sort of two groups. One were the mathematicians, the rest were the art students, French literature. Now, for the mathematicians, these guys, they prided themselves in logic and they thought they were really good. And they honed their analytical skills to a razor's edge. The second group, on the other hand, kept pace with the mathematicians. However, they started to diverge from the mathematicians in two important ways. One, they started playing fast chess, which is roughly 5 to 10 minutes per game. And if you've ever played that, it's just one move after another. There's no time to think. So essentially, it's instinctual. And the mathematicians didn't like this because they weren't able to use their logical skills. And the second element was they reproduced the games of the Grand Masters. So anybody want to guess as to which group produced the master players? Okay, let's go on a bit. The first group, the mathematicians, were very, very good at their game. They relied on rules, they relied on logic, but they did not go beyond that. The second group, the use of fast chess as a game-playing technique allowed them to experience or to gain much more game experience than the mathematicians. Likewise, by reproducing the games of the Grand Masters, they gained the experience of the Grand Masters. Does this sound familiar? Look at other people's code, go to code inspections. So it's no secret, it's the non-mathematicians produced the master players. I don't know if any of them went on to be grandmasters. But the whole point that I'd like to make is that doing your job is not enough. You need to expand your domain knowledge. You need to read. You need to write, or you need to read articles, write code, build stuff. You need to participate in master classes, teaching, whatever you can. Help others, and you will help yourself as well. The last item that I'd like to discuss here is the importance of attitude. And what I mean by attitude here is is a person's attitude when it comes to their abilities. Now, Carolus Dweck, I believe she's a professor at Harvard, discovered that even amongst the university educated, people were divided down the middle. One half believed that they were, intellectually superior, and everything that they did was based on intellect. Whereas the second group believed that it was hard work that got them to where they were. So let's look at the first group. These people, the fixed attitude types, again, their intellect is everything. They're smarter than everybody else was. And I'll just confess here that I belonged to this group at one time. I thought, but the problem is with this group is that they're vulnerable to failure, and they'll avoid tackling difficult problems. And you may wonder, why is this? Well, when you have an attitude that your intellect is superior to everybody else's, and you don't recognize what really gets you to the top rungs of achievement, you will avoid anything that will challenge that assumption. So therefore, if they flunked the test, well, yeah, it's because I didn't study, not because it didn't work. Likewise, and what's more insidious is that if you attempt to give people with a fixed attitude any feedback, they'll view it as a personal attack. Now, the good thing is that once you become aware of this, it's fairly easy to change your attitude. So let's look at the second one, second group here, people who believe that they are works in progress. These are people that believe that their intellectual capabilities can be improved, and the key thing is that they view hard work as the key to success. If they fall down flat on their face, they'll pick themselves up, dust themselves off, and go on, and use that failure as a learning experience. Likewise, they'll welcome feedback, and the thing is, they'll soon outperform their fixed ability colleagues. So why should we do this? I mean, why should we study? Why should we work hard? Well, software development, it's not bricklaying, it's not construction work, it's an intellectual activity. And if we work hard, our intellectual abilities can be improved to a razor's edge. And if we want the jobs, the assignments, then it behooves us to try and improve ourselves to be the best that we can. As a company, we want the situation where customers want our products, not because we're the only one on the market, but because our products are great. Okay? And likewise, a more important effect is that if you're striving for individual excellence, that becomes the foundation and basis of team excellence. So that's the end of my talk, but just to summarize, these are the 5 themes of deliberate practice. Setting goals, very, very important. There's a number of techniques to acquire knowledge, apply what you learn, but the most important really is get feedback. Find out how you're doing. Are you doing well? Are you doing badly? No matter how painful. And don't forget that we're all a work in progress, and that any improvement, starts by taking small steps. Okay, I've got a recommended reading list here. It's probably too much to write down, and of course, contact information if anybody wants to talk to me about this or anything else after. Okay, are there any questions? Okay, thanks very much.